What's going on? We're moving on with chapter 9 and lesson 9.2, circumference and arc length. Okay, so to review, sorry, actually I lied. Make sure you go into Canvas. The notes are there. The notes are available, and the PowerPoint slides there are available as well. So make sure you pull up the notes and take those notes, or take your own set of notes while we're going through this. Okay, so review. Remember, the radius is a segment with endpoints being the center and somewhere on the circle's edge, and the radius is always half the length of the diameter. Okay, the diameter is a line that passes through the center, and endpoints are on the edge of the circle. A diameter is always 2 times the length of the radius. Okay, radius is half of a diameter. Diameter is 2 times of a radius. Okay, so the equations for diameter, right? If you are looking for a radius, the radius is equal to the diameter divided by 2, or the radius is equal to 1/2 times the diameter. Those are the same thing. Right, and the diameter is equal to 2 times the radius. Okay, and if you think about it from an algebraic standpoint, these are the same exact equations, just manipulated in different ways to be able to find what you're looking for. So if we take example, the r equals d over 2, I don't like that color, but such is life, right? If we want to know what the diameter is, to get rid of divided by 2, we multiply that by 2. And those cancel out, and then you just end up with d equals 2r, which is, again, like I said, the exact same equation, right? And it's the same thing. If you wanted to manipulate the diameter equation to give you the radius, right, you want to know what radius is, so you divide both sides by 2, right? And then you end up back with r equals d over 2. So they're the same equation, just different ways of finding if you're looking for the diameter or the radius. Okay, so some examples. If QV is equal to 8 inches, what is the diameter? Right, so QV, right, that is a radius, and if that radius is 8, that means the diameter would be 8 times 2, which is 16. Okay, if TU equals 14, if I get a different color, if TU, that's a diameter, is 14, excuse me, that means the radius would be half of 14, which would be 7. Okay, and if QT equals 11, that is a radius. What is QU? Right, QU is also a radius, so that one would also be 11. Okay, that one was a little bit different, right? But they're both radii, or 2 radii. That's the plural form of radius. You can't say radiuses; it's radii. They are both radii, so therefore they are the same length. Okay, circumference is the distance around a circle, right? Think about, we haven't talked about that in this class, but I'm sure you've learned this sometime in your mathematical career. When we think of perimeter of like a square or something like that, perimeter is the distance around the edge of a shape. Circumference is just a word, is how we say the perimeter of a circle, right? So the circumference is the distance around a circle. There's 2 equations to find the circumference, depending on if you have the diameter or if you have the radius, right? Circumference is equal to pi times diameter, or the circumference is equal to 2 times pi times the radius. And if you think about it, right, those are interchangeable because we know that the diameter is 2 times the radius anyways, right? So if you have the diameter, you do diameter times pi. If you have the radius, you do 2 times radius times pi. Or C is circumference, D is diameter, and R is radius, right? So pi, this is a bunch of just fun facts about pi. You don't have to write all of these things down, but I think it's very interesting, right? So pi is the ratio of circumference over diameter, no matter how large or small a circle is. If you divide the length of the circumference by the length of a diameter, it will end up being roughly 3.14, blah, 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 okay? So pi is an irrational number. It means that the decimal continues forever and never, ever repeats. Right, the first found recorded use of pi as a mathematical symbol comes from the Welsh mathematician William Jones in 1706, called that. I'm not even going to attempt to say that, in which he abbreviates the Greek word, whatever that Greek word is, and that Greek word means circumference or periphery, right? But since that word starts with pi, he apparently decided to just shorten it to pi. So once again, pi is a Greek letter, right? It's a letter in the Greek alphabet, and it's used to represent this number that's 3.14, blah, 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 right? And like I said, that's the first found recorded use of pi, being the symbol to represent 3.14, but I guarantee you that it has been used for a lot longer than that. It's just the first place that we found it. All right. Even though it wasn't actually called pi at the time, pi has been seen being used in ancient Egyptian and Babylonian math from as far back as 2000 BC. So again, it may not have been called pi, but the 3.14, the ratio of pi, has been used for almost 4,000 years. Okay, here are the numbers of pi, only the first 500. So like I said, it is a decimal that just continues on forever and never, ever, ever, ever repeats, right? These are just the first 400 letters: 3.14159265358979932, blah, 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 right? And someone memorized over 100,000 numbers of pi. That is absolutely craziness. I couldn't even probably get through 20 numbers even if I tried. All right, so just some fun facts about pi. Okay, some examples. Find the circumference of the circle. Right, remember circumference. If I write the equation up here at the top, right, the circumference can either be diameter times pi, or the circumference can be 2 times the radius. That's a r. 2 times radius times pi. Okay, so if this one here is given us 11, that is a radius. So that means circumference is equal to 2 times the radius times pi, right? Which becomes 2 times 11 times pi, right? And you can use a calculator, or right, 2 times 11. And if you are using a handheld calculator, there is a pi button, so you could type that pi, and that would technically give you a more accurate answer, or you can just multiply it times 3.14. right, which comes out to the circumference is equal to 69.08, which would then round to 69.1. Okay. Over here, 22 is given as a diameter, so the circumference of a diameter needs to be circumference equals diameter times pi, right? Which, as you can see, 2 times 11, 2 times this radius gives you 22. So that means these are actually going to be the same thing. Fun facts, right? So that would be 22 times pi, right? And if you type that into a calculator, 22 times pi, or 22 times 3.14, the circumference comes out to 69.1 again. Okay. Okay, some more examples talking about just the diameters and radius, and finding new lengths there, right? The diameters of circle A, B, and C are 8 inches, 18 inches, and 11 inches respectively. So that means, not triangle, circle A, right? The diameter, so the entire length of circle A is going to be 8 inches. If I use a different color, the entire length of circle B, right, diameter, is 18 inches. And then if I use another color, let's go with green, right? The diameter of circle C, which is the whole thing, remember, is 11 inches, right? Find each measure, right? So if we're looking for segment FG, right, let's take a look. Let's see where FG is at. If I use even a different color, F is here, right? And it goes all the way to G, which is right there. All right, so that means we know that this whole length here is 18, right? But FG is minus this little part of the red area. And you can see that that little half there is a radius of circle A, right? Because if I use that red color again, right, the part that is not included in FG is the radius of circle A. And if the diameter of circle A is 8, that means the radius of circle A is 14, right? So that means we have the diameter of circle B is 18, but we subtract this little area here, so it would be 18 minus 4, which comes out to 14. So that's be the length of segment FG there, right? Segment FB, let's take a look. What are we looking for here? If we try and use a different color, I understand that it's getting a little hectic, right? There's F, and it goes to segment B, which is there, right? So that means, once again, we know that this little piece is 4, and now we know that half of the length of this diameter of circle B would be 9, because the diameter is 18, so the radius of circle B would be 9, but the radius of circle A is 4, so that one would come out to 9 minus 4, which is 5. That is how you figure those out. Okay, arc length. Last lesson we learned how to find the measure of an arc angle. This lesson we learned the length of the arc itself. Okay, so if you think let me just take a look, right? Last lesson, we learned out how to find the angles of the arc. Now in this lesson, we're actually going to find out like what is the length, like a physical distance of an arc. Okay, so that's the difference between what we learned last lesson and this lesson. Okay, so arc length is the ratio of the length of an arc to the circumference is equal to the ratio of the degrees of the arc to 360, right? So that means the length of the arc divided by the circumference of the entire circle has to be equal to the ratio of the degrees of the arc divided by 360. Right? And if we're looking for length, right, if we think about this algebraically again, if we're looking for length, you multiply both sides by circumference, which is ended up being this equation over here. So length is equal to circumference times degrees of the arc divided by 360. Okay, and here is a more accurate, or maybe a nicer picture of what that is. So arc length is equal to 2 pi r because that is the equation of the circumference, right? 2 pi r is the equation for circumference times theta, which is the angle, divided by 360, right? And that kind of makes sense. If we know the degrees of the angle, right? If we divide that by 360, that makes up the percentage of the circle. And then if we multiply that percentage by the arc length, right, or times the circumference, that would give you that percentage of the circle, which is that arc length. Okay, so examples, find the length of arc ZY. So if I write the equation up at the top, right, the arc length is equal to the circumference times theta divided by 360. And remember, circumference is diameter times pi, or instead it could be 2r times pi. Okay, so that's all we're going to do here to find out these lengths of the arcs here, right? So the length is circumference times theta divided by 3. Oh, that should be 360. Sorry about that. Right. So the circumference of this, right, this is a radius. So that means the radius is 4, which means that would be 2 times 4 times pi times theta. The angle here is 75 degrees divided by 360. Okay. And now we just type those into the calculator. Remember, that's supposed to be pi. That's bad writing. Shocker, Mr. Stanton having some bad writing. All right, so we do 2 times 4 times pi, or times 3.14. That gives you 25.12. 25.12. And then we do 75. Oh, I keep forgetting the 0. 75 divided by 360 gives us 0.208. All right, 0.208. And then we multiply those two together times 25.12. which gives us about 5.23, and the 3 is repeated. All right, 5.23, and the 3 is repeated. Okay, now find the length of arc ZY here. Once again, this, if I use a different color, right, arc ZY is this, right? Remember, filling in there, length is equal to the circumference. Now we're given the diameter, so the circumference is 10 times pi, times theta. This time the angle is 130 degrees divided by 360. Almost forgot the 0 again, right? So then we do 10 times pi, which, if you think about it, 3.14 times pi gives you 31.4. And then 130 divided by 360 gives you 0.36. Right, and then 0.36 times 31.4 leaves you with 11.33. 11.338, right, which would technically just round to 11.3. Okay, so that's how we find the length of arc ZY. I believe that is it. Yep, that is it. Have a great day. Go Mustangs.